Crawler tracked equipment for progress in agriculture, in petroleum exploration, in soil reclamation, in construction work. The application of this type equipment is increasing everywhere. The direct contact with the soil by the undercarriage of these machines results in high operating costs. The goal of Berco is to manufacture high-quality parts of perfect interchangeability at competitive prices to reduce hourly operating costs. The purpose of this film is to illustrate the plant facilities, production equipment, and quality control methods used to assure a continuance of the high-quality level of Berco, recognized throughout the world as a specialist in the manufacture of undercarriage parts. We are now over the manufacturing facility of Berco, belonging to Bertoni and Cotti. The plant is at Copparo, in the province of Ferrara. The land area is over 591,000 square feet, with 296,100 square feet of covered plant area. Bertoni and Cotti was founded in 1918. The firm continually expanded due to the determination and engineering capabilities of its founder, Vezio Bertoni. John Bertoni, son of Vezio Bertoni, joined the firm 10 years ago, and the joint efforts of father and son have greatly expanded the range of products manufactured by Berco. In addition to the spare parts division, the Berco machine division manufactures equipment used for repair of motor vehicles and marine engines, plus machine tools, hydraulic, stationary, and portable presses for tractor repair work. The Berco machine division manufactured many of the high production tools used in making Berco tractor parts. The spare parts division manufactures the highly expendable undercarriage parts for tracked equipment as follows: sprockets and front idlers, lower track rollers, upper track carrier rollers, track rails and track groups with shoes, teeth for excavators, sprocket weld on rings, segmented type sprockets and segment groups, final drive pinions and bull gears, conventional and lifetime seals. In addition to spare undercarriage parts, Berco also supplies various European and American equipment manufacturers with original undercarriage equipment components. Berco has its own cast iron foundry at Cadoneghe in the province of Padua, and its own steel foundry at Badia Polesine in the province of Rovigo. This allows Berco to control the availability and quality of castings. Here you can see the casting, the mold shakeout, cleaning and grinding drive sprockets in the steel foundry in Badia, Polesine. Berco uses large quantities of steel obtained from the best common market steel mills. Berco uses 120,000 tons of steel billets, bars, and special sections per year. Here we see the huge amounts of raw materials needed to assure a continual flow for volume production. The material is first checked out here in order to assure that the steel characteristics meet the essential quality level of Berco production. Bar after bar is checked by spark test in order to eliminate mixing of steel of different analysis. Several samples are also obtained from each group of billets and bars. These samples are sent to Berco's modern laboratory for sequential X-ray spectrometer analysis to determine the quantity of all the chemical elements in the steel and to assure that quality requirements are met for ultimate hardness and grain flow characteristics of finished parts. Aluminum and copper alloys are checked before utilization in the production line. Here are parts being sectioned and checked to further maintain a high quality level of finished parts. In addition, the laboratory conducts tests to determine heat treatment methods and material choice in order to obtain the proper hardness and metallurgic structure to meet extreme operating conditions. After the tests are completed, the material is transferred to the press forging department for production in one of the best equipped shops specializing in this type of production. The billets are preheated in a tunnel-type furnace to eliminate cracking during the shearing operation. The billets are sheared to the proper length and weight, and then forwarded to the various pressing and forging production lines. These are composed of sturdy, powerful machines served by gas or electric-fired induction furnaces and of mechanical presses for trimming and coining the pieces. We can see here the pressing of a roller flange. The operation is carried out in the following sequence. The steel billet is heated in a gas-fired furnace to 1200 degrees centigrade. The billet is removed from the furnace to receive the first rough form and deslagging. It is then drop forged. Trimmed. And coined by means of a mechanical press. Here's another hammer in the same sequence of forging. A single flange roller, a shaft, a sprocket segment, and here is the automated system of pressing double-flange rollers. The 2,800-ton friction press, fed by induction heating, performs this task in a fast and efficient manner. You have seen the press forging methods employed to obtain the best grain structure in the steel in order to obtain high resistance to severe mechanical stress. Again, we see electrical induction furnaces heating sheared billets, which are being forged into track links by mechanical presses. Production of links exceeds 8 million units per year. Hot press forging is followed by automatic and semi-automatic machining operations grouped in special lines to assure good production flow. Automatic boring mills are used to machine front idlers and sprockets. automatic broaching machines are used to make splines on sprockets. The splined area is then carefully checked to assure proper fit with the final drive hub. More machines are used to rough turn rollers. The roller bores are machined with centimillimetric accuracy with automatic lapping machines. This automated equipment flashes a green warning light when the parts are within perfect tolerance and finish. Machining of bushing assemblies and collars is carried out on other production lines. Machining shafts is carried out on this special production line according to the following sequence: turning, milling, drilling, and grinding. The machining cycle is thus concluded. Here we see machining of seal rings. And machining of sprocket segments. This department is designed to machine track links. The machining is done in the following order: milling links 2 by 2, boring and drilling, broaching the flat area for the track shoe nuts, a 100% inspection is made to assure proper fit. Here we see the cutting of track pins to length and grinding. drilling and boring of bushings, and lastly, working the outside diameter. Heat treat department. Heat treatment is very critical for the parts produced at Berco. The essential technological characteristics are maintained at a high level. The track bushings are placed in a container and case hardened in pit furnaces, whose carburizing atmosphere is controlled by means of infrared ray equipment. The bushings are then removed from the container and air-cooled. The bushings are then heat-treated with induction heating followed by water cooling. The ends of the bushings are induction tempered to eliminate cracking. The bushings are then tempered completely in pit furnaces. A special differential heat treat is used on the track rollers to obtain particular microstructural and hardness values in order to obtain good wear characteristics and resistance to flange breakage. Here, special furnaces are used to heat parts to temperature, and special fixtures are used for water jet quenching. Links are first hardened and tempered. They are placed in furnaces and heated, then quenched in large tanks with proper additives. The links are then tempered in pit furnaces. The link wear area is surface hardened by progressive or simultaneous induction heating and water cooling, followed by stress relieving in a cyclone furnace. Medium frequency induction hardening methods are utilized for the wear surfaces of pins, shafts, front idlers, sprockets. Tests are carried out with durometers and magnetic fluorescent equipment to reject parts that do not conform to prescribed quality levels. The mechanical characteristics obtained from the steel by the heat treating methods results in remarkable resistance under severe operating conditions. These methods obtain high hardness on the outside surfaces with a strong, tough core as a result of the proper hardness gradient between the differential hardened zones. The quality obtained results in a long-lasting product, plus a savings in operating cost. The track shoe department has expanded remarkably in the last few years. The raw material is obtained from the steel mill in a rolled bar of the proper cross-section. It is then cut by multiple oxygen propane torches. The shoes are then hardened and tempered in an automatic continuous furnace that oil hardens and tempers to the correct hardness. The operations are then followed by hardness tests and checked by magnetic fluorescent equipment to detect the presence of possible cracks. The shoes are then drilled, hole spacing checked, and then part of the shoes are painted and forwarded for packing. The balance of the shoes are assembled into track groups. The track bolts are tightened to the proper torque with special wrenches. The finished parts are transported to the assembly area. The Berco designed and manufactured presses are shown assembling track links. The presses were designed for fast assembly work. As you can see, a 100% test sees that the proper hole spacing matches the Grouser shoe. The rail assemblies are wound on special Berco machines, then properly secured and forwarded to the painting department. This department's function is assembling component parts for lower track rollers, upper carrier rollers, front idlers, segmented sprockets. The parts used are carefully washed, then assembled, lubricated, and coated with rust-resistant paint, which prevents oxide formation even in the event of long exposure to sea air. The assembled parts and components are stored and then, when required, forwarded to the shipping department for careful packing. Pallets, cases, plastic material, and other innovations are used to guarantee safe arrival of the parts, no matter how distant the destination. The entire Berco activity employs a labor force of 2,300 people. quality workmanship of Berco has resulted in continued expansion of production facilities and a steady increase in demand for Berco products throughout the world. Berco is pleased to have this opportunity to show you the investment it has made in order to manufacture parts that will reduce maintenance cost of tracked equipment through competitive prices and longer lasting parts.